ਹੈਲੋ ਸਟੂਡੈਂਟਸ ਵੈਲਕਮ ਬੈਕ ਟੂ ਮਾਈ ਚੈਨਲ ਪਲੇ ਵਿਦ ਸਾਇੰਸ। ਅੱਜ ਦੀ ਵੀਡੀਓ ਦੇ ਵਿੱਚ ਆਪਾਂ ਕਰਨ ਜਾ ਰਹੇ ਹਾਂ ਪੰਜਾਬ ਸੈਕੰਡਰੀ ਐਜੂਕੇਸ਼ਨ ਬੋਰਡ ਦਾ ਸਾਇੰਸ ਦਾ ਕਲਾਸ 10th ਦਾ ਲੈਸਨ ਨੰਬਰ 3 that is metals and non-metals. So let's get started. First of all, to identify whether a given element is a metal or non-metal, we need to classify their physical properties. The main physical properties of metals are malleability, ductility, sonority, luster, hardness, conduction of electricity and heat, melting and boiling points, and their physical states. An important question from exam point of view is to differentiate between metals and non-metals on the basis of their physical properties. As you can see on the screen, you have to write the answer in this manner. You have to make a table and differentiate between metals and non-metals. Metals are malleable and ductile. Non-metals are not malleable and not ductile. Metals are good conductors of heat and electricity, whereas non-metals are poor conductors of heat and electricity. Similarly, metals are lustrous, non-metals are non-lustrous. Metals have strong tensile strength, they are strong. Non-metals have low tensile strength. Density, metals have high density, non-metals have low density. So in this manner you can differentiate between metals and non-metals on the basis of their physical properties. Next we have to discuss the chemical properties of metals and non-metals. As you can see on the screen, similarly, you have to again make a table and differentiate between the various chemical properties of metals and non-metals. From exam point of view, this question is also very important. You usually get this question in exams to differentiate between metals and non-metals on the basis of their chemical properties. If you get a question in general without mentioning physical or chemical properties, then you can write about physical properties also, you can write about chemical properties also. Now let us discuss them one by one. Nature of ions. Metals are electropositive elements, hence they lose one or more electrons to form the positive ions, whereas non-metals are electronegative elements and hence gain one or more electrons to form the negative ions. Examples are written on the screen. Second chemical property is nature of oxides. Metals usually form basic oxides. For example, sodium Na dissolves in water to form bases which turn red litmus blue. Non-metals form acidic oxide. For example, oxides of nitrogen dissolve in water to form acids which turn blue litmus to red. Reaction with water or steam. A large variety of reactions can take place according to the reactivity of metals. Some active metals like sodium, calcium, potassium, aluminium, etc. displace hydrogen from water or steam. Non-metals generally do not react with water. Next chemical property is oxidizing and reducing behavior. Metals have strong tendency to lose electrons and hence behave as reducing agents, whereas non-metals have strong tendency to accept electrons and hence behave as oxidizing agents. Next is reaction of metals with water. As we have already discussed, metals react with water to form a metal hydroxide or metal oxide and hydrogen gas. All the metals, however, do not react with water. The intensity of a reaction with water depends on its chemical reactivity. Some metals react even with cold water, some react with hot water, some react only with steam, whereas others do not react with water. For example, reaction of sodium and potassium with water occurs even at room temperature and is vigorous and exothermic. A large amount of heat energy is evolved that allows hydrogen gas to catch fire easily. The reaction of calcium with water is less violent. The heat evolved is not sufficient for the hydrogen to catch fire. Metals like aluminium, iron, and zinc do not react either with cold or hot water. Now, when metals react with water to form oxides and hydroxides, though most of the metal oxides are basic in nature, but some of the metal oxides show basic as well as acidic nature. These metal oxides, which show both basic as well as acidic behavior, they are known as amphoteric oxides. For example, aluminium and zinc, these both metals form amphoteric oxides. Usually, non-metals do not react with water except for chlorine. Chlorine dissolves in water to give an acidic solution. Now you will come across with the term that is aqua regia, Latin name for royal water. Aqua regia is a freshly prepared mixture of 1 part of concentrated nitric acid and 3 parts of concentrated hydrochloric acid. It is a highly corrosive fuming liquid. It is one of the few reagents that is able to dissolve gold as well as platinum. Now let us discuss the reactivity of metals. We are again and again saying it depends on the nature of the metal, whether it is reactive, less reactive, highly reactive or non-reactive. Now as you can see on the screen, the reactivity series of metal, the metals are arranged in the order of low reactivity to high reactivity. A column has been made. It is very easy to learn this reactivity series of metals. For example, I have decoded it as with the symbols of elements. Potassium is written as K, sodium is written as Na, and calcium, magnesium, aluminium are written with symbol CaMgAl. So I have made a little song to learn this, like Katrina ne car mangi, Alto, Zen Ferrari, फिर भी क्यों मिली सिल्वर ऑडी. कैटरीना मीन्स के, कैटरीना ने एन ए, कार सी ए, मांगी एम जी, ऑल्टो ए एल, जेडन, फरारी एफ ई. फिर भी पी बी, क्यों सी यू, कॉपर, मिली, मर्क्यूरी मिली एच जी symbol, silver is ag, and gold au gold, silver odd, au odd. So I think you can easily remember this reactivity series with this easy method. At the bottom of this reactivity series are the least reactive metals, silver and gold. You might have seen ladies wear gold and silver ornaments because they do not react with air and moisture easily and do not get corroded. On the upper side of this reactivity series are the elements like potassium and sodium, which are the most reactive metals, and they react vigorously with air and water and catch fire. This is the reason why sodium is stored in kerosene oil. Then comes calcium, magnesium, aluminium, zinc, iron. These are the elements which are put in the middle of reactivity series. On the right hand you can see these are the methods written here for extraction of these metals from nature. We will discuss them later on in this same video. Now let us discuss the reaction of metals with non-metals, yani ki how do metals and non-metals react. Let us understand in detail. Here you can see we have discussed already. Metals are electropositive in nature. That means metals have the tendency to lose electrons present in the outer shell and form positive ions. Similarly, non-metals like chlorine written here, they have the tendency to gain electrons and become electronegative ions. Here sodium has been converted to sodium ion and chlorine is converted to chloride ion. Now these two ions react together and the compound formed in this manner by the transfer of electrons from a metal to a non-metal is known as ionic compound or the electrovalent compound. These electrovalent compounds have some properties which we need to learn. So let us discuss the properties of ionic compounds. First is physical nature. Ionic compounds are solid in nature and comparatively harder due to strong electrostatic force of attraction present between the ions of ionic compounds. Melting point and boiling point. Strong interionic attractions are present between ions of opposite charges. Thus, to break the ionic compounds, more energy is needed. Thus, the melting points and boiling points of ionic compounds are very high. Third property is the solubility. Electrovalent compounds are generally soluble in polar solvents like water and insoluble in non-polar solvents like carbon tetrachloride, benzene, ether, alcohol, etc. Fourth property of ionic compounds is the conduction of electricity. The conductance of electricity in any substance is due to the movement of charged particles. The ionic compounds exhibit electrical conductance due to the movement of ions which are present in the molten state or in the soluble state in the polar solvents like water. So I hope you got the points. Now let us discuss the occurrence of metals. Beta, from where do all these metals come? All metals that are present in the Earth's crust occur either in free state or in the form of their compounds. The elements or compounds which occur naturally in the earth crust are known as minerals. Now, minerals again is an important term. At some places, minerals contain a very high percentage of particular metal and the metal can be profitably extracted from it. These minerals are called ores. Again, ore is also an important term. From examination point of view, you can get a question that is differentiate between minerals and ores. Now let us discuss how these metals are extracted. So to extract the metals, ores mined from earth are usually contaminated with a large amount of impurities such as soil, sand, etc., which is called gangue. The impurities must be removed from the ore prior to the extraction of metal. The process used for removing the gangue from the ore are based on the differences between the physical and chemical properties of the gangue and the ore. Different separation techniques are accordingly employed. Now, to discuss the extraction of metals, we again need to discuss the reactivity series of the metals. On the basis of their reactivity, metals are differentiated into three categories: metals of low reactivity, metals of high reactivity, and metals of middle reactivity. Metals low in the activity series are unreactive. The oxides of metals can be reduced to metals by heating alone. For example, cinnabar (HgS) is an ore of mercury. When it is heated in air, it is first converted into mercuric oxide, yani HgO. Mercuric oxide is then reduced to mercury on further heating. The metals in the middle of the activity series such as iron, zinc, lead and copper, they are moderately reactive. They are usually present as sulfides or carbonates in nature. It is easier to obtain a metal from its oxide as compared to its sulfide and carbonate. Therefore, prior to reduction, the metal sulfides and carbonates must be converted into metal oxides. These are converted into oxides by heating strongly in the presence of excess air. This process is known as roasting. The carbonate ores are changed into oxides by heating strongly in limited air because in carbonates oxygen is already present. So this process is called calcination. You can get a question to differentiate between roasting and calcination also in the exams. Now, you are already familiar with the process of oxidation and reduction as explained in chapter 1. Obtaining metals from their compounds is also a reducing process. Besides using carbon or coke to reduce metal oxides to metals, sometimes displacement reactions can also be used. The metals high up in the reactivity series are very reactive. They cannot be obtained from their compounds by heating with carbon. Carbon cannot reduce the oxides of sodium, magnesium, calcium, or aluminium to their respective metals. This is because these metals have more affinity for oxygen than carbon. These metals are obtained by electrolytic reduction. For example, sodium, magnesium, and calcium are obtained by the electrolysis of their molten chlorides. These metals are deposited at the cathode, that is the negatively charged electrode, whereas chlorine is liberated at the anode, that is the positively charged electron. Similarly, aluminium can also be obtained by electrolytic reduction of aluminium oxides. Now, when we get the metal from their oxides, the metal produced by various reduction processes is not very pure. Still, the metals may contain some impurities which can be removed to obtain pure metal. So, various methods are used to obtain the pure metal. One of them is electrolytic refining. In this process, the impure metal is made the anode and a thin strip of pure metal is made the cathode. A solution of metal salt is used as electrolyte. On passing the electric current as shown in the diagram, the pure metal from the anode dissolves into the electrolyte. An equivalent amount of pure metal from the electrolyte is deposited on the cathode. The soluble impurities go into the solution, whereas the insoluble impurities settle down at the bottom of anode and are known as anode mud. So in this way we get the pure metal from their minerals or ores. You can also get a term to define, that is metallurgy. The extraction of metals from their ores and their refining is known as metallurgy. Next topic we are going to discuss is the corrosion. The surface of some metals such as iron is corroded when they are exposed to moist air for a long period of time. This phenomenon is known as corrosion. Silver articles become black after some time when they are exposed to air. This is because it reacts with sulfur in the air to form a coating of silver sulfide. Similarly, copper reacts with moist carbon dioxide in the air and slowly loses its shiny brown surface and gains a green coat. This green substance is called copper carbonate. Iron, when exposed to moist air for a long time, acquires a coating of a brown flaky substance called rust. So all the metals which we have discussed, they come in contact with the air moisture and get corroded. Corrosion is a very serious problem because it damages the upper layer of metals, and every year a large amount of money needs to be spent to maintain these metals, their strength as well as shine. So to avoid this problem of corrosion, we can adopt some preventive measures. First one is by painting, oiling or greasing the top surface of metals to prevent their contact with air and moisture. Second method we can use is galvanization. Galvanization is a method of protecting steel and iron from rusting by coating them with a thin layer of zinc. The galvanized article is protected against rusting even if zinc coating is broken. Next method is chrome plating. It is a technique of electroplating a thin layer of chromium into a metal object. Next method we can follow is anodizing. It is an electrolytic passivation process used to increase the thickness of the natural oxide layer on the surface of metal parts. Last method, fifth one, is alloying. It is a very good method of improving the properties of a metal. Corrosion can also be reduced by this method. For example, iron, the most widely used metal, it is never used in pure state. This is always mixed with a small amount of carbon. It becomes hard and strong. When iron is mixed with nickel and chromium, we get stainless steel, which is hard and does not rust. Thus, if iron is mixed with some other substance, its properties change. The substance added may be metal or a non-metal. So here comes a new term, that is alloy. Alloy is a homogeneous mixture of two or more metals or a metal and a non-metal. It is prepared by first melting the primary metal and then dissolving the other element in it in definite proportions. It is then cooled to room temperature and used accordingly. Some common examples of alloys are brass and bronze. Next topic we are going to discuss is the important points to remember before finishing this chapter. First is the differences between metals and non-metals. Second, differences between ores and minerals. Third one is some terms which you need to learn. What is gangue, electrolytic refining, amphoteric oxides, activity series, metallurgy, alloy, corrosion, and important term is aqua regia. I hope you all have understood this chapter thoroughly and you are now ready for your exams. Now, important questions from this chapter you need to search for. First one is why gold and silver are not used in pure form to make jewelry. Second question is what are amalgam and solder. I hope you liked the video. Do like, share and subscribe. Thanks for watching.